Okay, again, I'm working the even trig identities, and I'm working backwards from 80 back because most of you all are getting the earlier ones during class. So these are the ones that if you didn't get to in class and you're having problems with, you'll have the videos on them. The first one we're going to work on is 74, then 72, then 76. Okay. This one is your 74. And what I'm going to do is write these two over a common denominator. So my common denominator is 1 minus sine times 1 plus sine. Again, if you want to rewrite this to just see what that looks like, that's 4 times sine over cosine times 1 over cosine. So you can either get this or you can get something that looks like this and have those two equal. Now when I do this, I'm going to multiply these two together and multiply these together because of the common denominator. And we get 1 plus sine squared minus 1 minus sine squared. And you're going to use your formula, put it over here, of a plus or minus b squared equals a squared plus or minus 2ab plus b squared. Alright. So in the top we have 1 plus 2 sine plus sine squared. That's this part. Minus 1 minus 2 sine plus sine squared. Alright. And this is all over 1 minus sine squared. Now, I'm going to try to get this all on this page here. So we get 1 plus 2 sine plus sine squared minus 1 plus 2 sine minus sine squared all over, and I'm going to write this as cosine squared. And the reason I'm writing this as cosine squared is because I come back over here and notice I have a cosine squared here. Cosine times cosine is cosine squared. Alright, we're going to clean this up. The ones will cancel. The sine squares will cancel. And I'm going to rewrite these two over here. So I'm going to have 2 sine plus 2 sine over cosine squared, which gives me 4 sine over cosine squared. Now, I can write this as 4 times sine over cosine times 1 over cosine, which equals 4 times tan times secant, which is, I believe, what we want. And we're done. So you have these two equaling each other. Okay, in 72, we are going to split this up. Again, kind of notice what this is. This is 1 over cosine. This is 1 over sine. So we either want this to look like this or this. Since this is all sine and cosine, I'm going to rewrite these in terms of sine and cosine, which is a sine over cosine plus cosine over sine. I'm going to write it over a common denominator, which is cosine sine, kind of crossing here. And I get sine squared plus cosine squared. That gives me 1 over cosine times sine, which is really what we have here. You can split this up and say 1 over cosine times 1 over sine, because 1 times 1 is 1, And then if you want, you could rewrite this as secant times cosecant, based on your identities. Okay, 68. My final answer, we want it to be 1. So what I'm going to do is I'm going to write all of these. I'm hoping on 68, this 1, and basically because I have this here, I'm hoping this is sine squared plus cosine squared. I might be wrong, but that's the route I'm going to go. So the first thing I'm going to do is write this as 1 minus cotan squared over cosecant squared plus 2 cosine squared. Now, at this point I'm going to put this denominator under each piece. This is 1 over cosecant squared minus cotan squared over cosecant squared plus 2 cosine squared. Okay. Now, I'm going to continue on. You might want to write notes here. Let me try to squeeze it in here a little bit. So what I'm going to do is break this down, and I'm going to write this as sine squared. So I'm going to write this as sine squared, and I'm going to break this part down on the next page. So I have sine squared minus cosine squared over sine squared over 1 over sine squared plus, don't forget this piece. That's what I tend to do. Now, at this stage, I can cancel out the sine squares. And I'm going to write this as sine squared minus cosine squared plus 2 cosine squared, which gives me sine squared plus cosine squared, which equals 1. So I have 1 equals 1.